So, hello everyone. It is 3 p.m. local time here in Germany, and we are ready to start with the webinar. So let's go. Yeah, it's a great pleasure for us to welcome you all to this exciting FDT webinar. We are very happy that you have signed up so numerously for our event today. We have a quite big and very diverse group. So I think currently we have more than 60 attendees. I think we had about 170 registrations, so I think we will get some more. Attendees from all over the world. I counted about 28 countries. So we have early risers from the US and Canada, from Colombia, Argentina, Brazil. So good morning to you all. As well as Nighthawks from China, from Singapore, Taiwan, and even Australia. So good evening to you. And of course, all over Europe and Africa, Arabia. So good afternoon. Yeah, my name is Michael Gunzert, and I am Director of Business Development here at CodeWrights. And it is our great honor to co-host this webinar together with the FDT Group. And therefore, I would also like to welcome Mr. Glenn Schulz, the Managing Director of FDT Group, who will be our speaker for today. Yeah, the topic of today's webinar is FDT 3.0 and how FDT can help you to accelerate and enhance your digital transformation. FDT has been very successful as a technology for device integration in the last 20 years. And based on this strong foundation, FDT 3 is a very exciting new technology with a much broader scope and great potential. So we are all very excited to bring this to the market now. Yeah, let me say a few words about the organization. So the webinar will take about 1 hour, and we decided that we would answer all your questions at the end of the webinar. However, you may ask your questions anytime during the webinar, and therefore you can use the questions feature of the GoToWebinar. That would be nice. Yeah, before handing over to Glenn, please allow me to give you a short introduction to CodeWrights. So CodeWrights, we are a software service provider specialized in industrial automation and device integration. Our offices are here in Karlsruhe, Germany, which is one of the leading IT regions in Europe. We have more than 30 highly educated professionals and work for more than 50 customers, well-known customers in process and factory automation. Yeah, being one of the pioneers in FDT technology, especially, CodeWrights has developed DTMs for more than 3,000 different device types. Next slide, please. Yeah, our offering includes industrial software development. So we do a lot of custom projects, integration solutions, of course, FDT DTM Development, iDTM, FDI development, as well as app development for mobile platforms, user experience design. We have testing services and also IIoT services and components available. Yeah, thank you. Next slide, please. Yeah, now let me introduce our speaker for today, Mr. Glenn Schulz. So Glenn joined the FDT Group as a Managing Director in July 2009. Before joining FDT, Glenn was the Managing Director and Vice President of Engineering at Dorna. And prior to that, for 13 years, he was executive at Rockwell Automation, with responsibilities including process industry asset management business. During his tenure at Rockwell Automation, Mr. Schulz served as a vice president and the secretary of the board of the FDT Group. He was instrumental in establishing the legal non-profit structure of the FDT Group that culminated with incorporation in Belgium as an AISBL. So that is kind of an international non-profit organization. He has numerous design credits, articles, and patents in the areas of real-time information-based material handling, industrial and process control security, asset management, cryptography, RF data transmission, low-power intelligent sensing technologies, electronic operator interfaces, and root cause analysis. Yeah, with that, I would like to give the virtual floor to Glenn. Thank you.
Thank you, Michael. Thanks for that kind introduction, and hello to everybody here today. Looking forward to this presentation and answering your questions as we go through. I will remind everybody that this session is recorded, and we'll make it available to you after the seminar, so that if you have colleagues that weren't able to attend and would like to see it, you're welcome to share that recording with them. And I particularly want to thank CodeWrights for organizing this seminar. As Michael mentioned, CodeWrights has been instrumental in the FDT Group since its inception. And as we get into this a little bit further, you'll see their signature on some of the standard and some of the deliverables of the standard. And many of their staff are involved, but I particularly want to recognize Dr. Gunzert, who is on our Architecture and Specification Committee, which is the group that actually authors the standards that the FDT Group eventually publishes and makes available to the industry. So thank you, Michael, for your great support of the FDT Group over all these years. A little bit about the agenda for today. We'll start out with just a little bit of the state of the industry as we see it in working both across the end user community and the vendor community in our industry. Talk about digital transformation with FDT3. We have a very diverse audience, as Michael mentioned, not only in terms of geography, but I think also in terms of your position in the industry. I see, and just glancing down the list, we have the vendor community here, we have the end user community, we have academia, and we have the press. And so we'll cover how you develop products with FDT3, and even if you're not a vendor, you may find that interesting just to see what a vendor goes through and the tools that are available there. Talk about the business benefits from various perspectives, what's all available today from an FDT3 perspective. We've got a demo for you of FDT3 applications. And then, as Michael mentioned at the end, we'll leave time to answer your questions. You're free to hit the questions tab in your toolbar and type out questions as you come across a topic that you have a question about. Or at the end, you can also raise your hand at the end of the seminar, and our moderator will open your mic so that you can ask your question live to the group if you choose to do it that way. So let's get started. A little bit about the state of the industry as the FDT Group sees it, and really what drove us into the creation of the FDT3 standard. So first, we serve a very diverse and fairly modern industrial automation marketplace. We got our start in the process industry. It was several process vendors that came together 20 years ago to author the FDT standard. But since then, it's been widely used in hybrid and factory automation as well. So now we span the entire automation space. And what we clearly hear when we listen to the marketplace is that people are looking for open integration. The old idea that you would go into a closed architecture with a particular vendor no longer is sufficient for the complex automation projects that are being developed. So some of the qualities there of open integration, people are looking for standardized ways of doing things, and often that translates to using international standards to lay out their infrastructure. There's clearly a move to a much more data-centric environment where data is accessible across the enterprise and not locked down in the OT side of the organization. Certainly, the advent of mobile devices has driven all sorts of new use cases to be able to access the automation environment from a mobile perspective, as well as remote access. And of course, the COVID situation that we're dealing with today has brought that to the forefront, that people need to get access to facilities when they are not present to be able to do their job. On the other side of things, definitely the idea of flexible architectures, and I think Industry 4.0 has probably done the most in terms of defining and driving some of this activity so that these architectures are much more scalable than they had been in the past. And probably the most interesting one is that they're much more agile, able to adapt and change to the product mixes and scale that may be going through those facilities. Certainly in our environment today, with so many things being interconnected through the internet, through VPNs and other means, is security and robustness are key to any of these architectures, and often many of the conversations start with security and then go on to the other aspects. And also compatible. Nobody wants to have to rip everything out and start over just to take advantage of some of these new environments. So what we see in a broad sense then when we listen to the marketplace carefully is that we're really transitioning from our thought today where a device is the object to the device moves out into more of a remote or virtualized fashion, and you would see that device on a smartphone or on a tablet and be nowhere near the device whatsoever, and yet equally capable of supporting that device and environment, even without being physically present. So from an FDT perspective, we are not an organization that develops communication protocols and those types of things. Our role in the industry is to sit above all of the networks that we deal with and all of the other standards that are there and help them to all interoperate. And so you can see we support all the communications protocols that you might be dealing with in your facility, or if you're a vendor that you might offer in your product line. And we also work with other key organizations in the industry like the OPC Foundation to have OPC UA compatibility and so on. But being a standard ourselves, we are recognized in the IEC standards organization, which most of the world accepts as a recognizable standard. And then in North America, we are an ANSI ISA standard as well. And a few years ago, thanks to the excellent work of our FDT China organization, we're now a national standard, a GBT standard in China as well. So we've covered not only all the protocols, but we've ensured that as a standard ourselves, that we're well recognized and accepted across the industry. So let's talk a little bit about what we wanted to accomplish with our new FDT3 standard. I'm not going to do a long history on FDT, but for those that aren't familiar, as Michael mentioned, we've been in the industry as a standard for 20 years now, and it has evolved throughout those years. And probably most people know us as a desktop single user type application because that certainly in the past had been the sweet spot for asset management, device management, those types of things. But given that changing environment that we just went through, it was obvious that our standard also had to adapt. So some of the things we looked at as we worked on this architecture for a new standard is that we had to build it from the ground up as a secure architecture. Certainly as you add these features, as you distribute people, as you distribute the architecture, if you do not have security first and foremost in mind, the rest of it really won't matter if you fail the security test. We also wanted to assure that it was standardized. We didn't want to abandon all the things that FDT was well known for across the industry. You have tens of millions of devices that are supported with the FDT standard, and we wanted to keep that standardization that we're so well known for in this new architecture. Prior to really kicking off the standard, we had done a large industry survey of end user, vendor community, and consultants and so on in terms of how did they want to access a new standard like this. And clearly, we started it as a mobile discussion, but clearly as we got into it further, we realized that the entire interface to the standard had to be web client-based type access, and we'll get into those details shortly. I mentioned the general notion that people are looking for rich enterprise information, and the new standard is completely information driven and also service oriented, so that you can expand the standard beyond simple asset management, adding things like apps on top of the standard that do unique functions either for a section of the marketplace, or even an end user would be able to add apps to do their unique requirements within their facilities. So we went through, to do this, we went through a lot of different use case scenarios before we started actually developing the standard. We went through mobility. What do people want? What are the use cases for mobility? And secure access from a field device, whether that's a phone or a tablet, was the typical use case. The idea is to improve the workflow for plant workers so that you don't need to return to a desktop, or you don't need to drag a notebook computer out with you out into the field. You should be able to work with the tools that you have available, and basically to enhance efficiency of the maintenance organization as well. Be able to get access to manuals, to troubleshooting guides, to wizards and so on, right when you're out in front of the device without having to lug other equipment with you. And then from a security perspective, we adopted a secure by design philosophy, and you're going to see shortly that the architecture for FDT3 is greatly expanded. And so we had to look at this from all the way down to the sensor perspective, all the way up to the cloud, and make sure we had a uniform security model for that environment. And then many of our large end users, particularly in the petrochem industry, adopt very strict security protocols where they will not even allow their automation system to be connected to the internet in any fashion. These are so-called air-gapped type facilities. And we took time to make sure we address the unique needs of air-gapped customers, as well, as this is a large segment for the FDT standard. And then we explained many times to our board of directors that when we have our end user conferences around the world, with our previous version of the standard, the number one thing we heard from our end users that they asked us to work on was getting access to the DTMs for the standard. So the DTM is the device driver for any device that you want to get access to through the FDT standard. And that DTM is almost always supplied directly by the device vendor. Well, with hundreds of vendors out there with DTMs, visiting all their websites, finding the right DTM for the particular device you have, and building a whole project that way can be a very daunting task. So we took the time in the FDT standard to define what we now call the FDT hub, where all the DTMs that are available for the standard are in that hub. It's a cloud-based device, a cloud-based environment, and all the DTMs up there are certified, and all FDT3 applications have direct access to that hub, so that as soon as you install a new device in your environment, the DTM for that device is immediately available to you through the API. We'll talk about that in a little bit more detail here shortly. So a lot is said in the industry about digital transformation, and I'd like to show you how, from an FDT perspective, we actually enabled this with our architecture. So central to our new FDT standard is the notion of an FDT IIoT server. In fact, that's where the FITS acronym comes from, is the FDT IIoT server. So often our FDT3 standard is known in the marketplace as FITS. And here's a look at the architecture of that server, and there's a lot going on here, and we'll walk through pieces of that through the bulk of this presentation and talk about what it means in terms of features, capabilities, business drivers, and so on within your organization. But to highlight some of the key features of the server is we can handle everything in a single server environment. So whether it's a particular line in a facility, whether it's the entire facility, or whether it's multiple facilities for an entire enterprise, a single server is able to support that activity. The interesting thing about the server is it was specifically designed to be highly scalable in size. So we can go down to something as simple as a skid. So for example, maybe an OEM is supplying a bottling line to your facility, and you want the OEM to be responsible for the productivity, the through rate, the asset management of that bottling line. They can embed a small FDT server in that bottling line to do those features. But that same server can scale all the way up to a full-blown cloud enterprise level server that can be running multiple facilities simultaneously. And it's all the same code. We do not have to change the code base for the different operating systems, and we don't have to scale the code to those different environments. So it's quite an impressive design. The security is built in to the architecture, so every point of ingress and egress that you see there in that architecture is protected through encryption, through industry standards that we'll talk about in just a minute. The entire standard has been written to be platform independent. So while in the past, most people implemented earlier versions of the FDT standard pretty much strictly on Microsoft platforms, that no longer is a requirement at all. You can put it on an Apple, a Linux, or a Microsoft platform with the same code. So it's completely platform independent. Inside the server as it's delivered is a native OPC UA server as well. This server gives you access to all the device data that that server has vision to. So if this server is serving an entire enterprise, you could get the data from all the devices for the enterprise. If it's on a skid, it can be getting all the data from the devices and networks on that skid as well. To support the mobility and remote access aspects of the requirements, we embedded a web server. So now the entire user interface, whether it's on a tablet, desktop, smartphone, whatever it might be, is strictly a web browser-based interface. So we're no longer dependent on a Microsoft desktop here. Any web browser, any major web browser can hit the server, and as long as you're authorized, you have access to the server, you can look at all of the data from the DTMs and the server itself. We maintain our heritage of allowing universal device integration, so you can mix any number of networks, any number of devices within the server. We're pretty agnostic from that perspective, so you're free to mix and match to your heart's delight to support your facilities or multiple facilities of your enterprise. And then as we started with the previous version of the standard, we have tools called common components. These are the developers' tools for companies that would like to develop products that are compatible with the FDT standard. And what the common components do is really pre-wire all of the features that are required to support the standard so that the vendor only has to focus on the issues unique to their product, device, or their software that they're offering. And this has greatly improved our interoperability and really speeds companies through the certification process so that they know that they're compatible with all of the other devices and systems that support the FDT standard. So from an open integration perspective, what this does is it really enables a whole FDT ecosystem to support the end user communities. So the FDT server allows distributed architectures for single or multiple facilities. You could even have a small server in a test lab, for example, or a prototype lab just to support that environment. We still maintain our ability to deploy this as an FDT desktop application for single user architectures where maybe you don't want to go through establishing the entire server environment. It's simpler just to put it on a desktop and run it for a specific project or specific line. That's still quite possible. The devices are supported by the DTMs, as I mentioned earlier, and these DTMs can either be provided by the vendor, or in the case of many networks where the devices are quite simple, we can also offer a generic DTM that is able to support all the basic devices for a particular network. Flexibility in the deployment architecture was key. As we went through the use cases, it was obvious that the requirements dictated a very flexible architecture, and we made sure we could do that. As I mentioned, this skid to cloud scalability is a real thing. You can run on a skid and a little Linux card on the skid and have the full capabilities of the server, or you can be a multi-facility enterprise scattered across the world and run a cloud-based instance of the server to support all those remote locations. Within the facility or for a facility, you can also move this from the cloud. You could put it on premise as a server, or you could put it somewhere on the edge of the enterprise with an edge-based device as well. And the architecture supports all those directly. We have the cross platform functionality. So you can run the server on one operating system, the clients can be on a different operating system, and you can be supporting 20 different networks, industrial control networks at the same time, all from that same platform. The FDT standard allows direct maintenance of devices, so you can drill through the architecture in a facility, through the project in the facility, and you can directly see individual devices and access them without regard to what network they're on or how many gateways you might have to pass through to get it. The standard automatically makes it appear as if you're connected directly to that end device. We support not only all of our standard industrial protocols, but of course, Ethernet backbones and so on from an IT perspective, so that the IT/OT integration that's so prevalent in our industry is readily facilitated by our standard. And of course, we have a rich heritage of installed base out there, and so we have backwards compatibility. The FDT desktop environment allows you to run any mix of DTMs from any of our standards from its inception through the FDT3 standard can be mixed in that environment. And we also allow FDI device package integration in here as well. And I think Michael will talk a little bit more about that later. So some key features of the FDT server is its integrated web server. This is so that everybody accesses the features of the server through a browser-based environment. It modernizes field device management because you no longer are bound to a desktop or some particular hardware to access a device. And it also transforms how you can do remote asset management. This would have been very difficult in past architectures to remotely manage multiple facilities. Now it really is a trivial use case with the features of the integrated web server. The OPC server, on the other hand, leverages a standard OPC client-based environment. So any OPC client that's authorized can connect to your FDT server and access all the data that it has available. This is enabling the IT/OT integration. So for example, if you wish to integrate some parts of your SAP business system and get real-time data from the plant floor to be able to do that, whether it's for performance metrics, for utilization, for output, or for maintenance work order activity, all that data is easily accessed through the OPC UA server that's built in. This whole issue of MES integration, enterprise connectivity, is well supported through the OPC UA server. And we also have support for the upcoming OPC UA pub sub environment, if you're familiar with that, where you do not have to continually poll the server to get data, but rather it advises you when data is changing that you're interested in. Of course, security has been key throughout this whole thing. So as I mentioned, we have not created our own concepts of security, but rather we leveraged well-vetted security standards that both the IT and OT organizations support and accept. So we have used TLS encryption throughout, and TLS, if you're not familiar with it, is really the underlying mechanism that you see every day when you go to a HTTPS type website, your bank or so on, when you're logging in. Under the hood, that's TLS that's doing most of that work. So it encrypts, but it also authenticates. So we use 509 certificates for authentication. And this enables us now to authenticate not only users, but we can authenticate devices that are authorized to access the FDT server in this environment. So quite powerful that way. And then, as we've always had, we've had role-based security for the users of the system. So you log in with your personal login credentials. And once you have done that, the system recognizes your role in the organization and gives you access to features in the server that are germane to your role. So just as an example, if you log in and you're in a maintenance environment role, you may not have the ability to change the project structure of the facility, but you certainly would have the ability to look at real-time device parameters, run diagnostics on the device, look at network health indicators to see if that's an issue for you, and so on. Conversely, if you're an engineer in the facility, you might have a very broad access role so that you can support the multiple disciplines within that facility. And then, of course, many of the protocols are the individual protocols on the industrial control side are starting to implement security within their protocols themselves. And probably the most prevalent example in our industry today is what ODVA has done with SIP security. And so our standards support that capability, so you can have secure industrial control networks as well. And several of the other network organizations are working on or are close to releasing their security enhancements to their protocol. And we'll continue to support all of those networks as they work to secure their standards. I mentioned this FDT repository that we call the FDT Hub. So the way this works is, and here you have a little closer view of it compared to that larger server slide earlier, the FDT Hub sits up in the cloud. Any vendor that creates a DTM for their device automatically places that DTM up in the cloud at the time that that DTM is certified as compatible with the FDT standard, and that's what you're seeing here. So a little bit about how this works. This was really, as I mentioned earlier, it was all driven by end user demand, and we've had just accolades from end users as they've seen that we've rolled out what they've asked for in this regard. And I think we actually improved on some of the concepts that were offered and how to do this. So this is a cloud-based feature, and the FDT Hub maintains this in the cloud. But for those users that have air-gapped facilities, we have made provisions so that we could have a dedicated on-site version for those customers who wouldn't allow cloud-based access. All the certified FITS FDT DTMs go up into this FDT Hub and are managed there directly by the vendors. So if the vendor has an upgrade to a DTM, they can go in there and upgrade that DTM. And if you have already downloaded that DTM into your server, you would then be notified that, oh, there's a new version of this DTM available. Would you care to take advantage of that? To actually get the DTMs, the really nice thing is there's almost no user interaction in this process. So it's a direct server to server communications. So it's not as if you have to log on and browse around for the DTM that you're looking for, but rather once you have a device on your network that is in need of a DTM, your server will automatically log into the FDT hub, ask for the appropriate DTM. It's downloaded to your server. It's verified through security protocols that it hasn't been tampered with, that it's just as it was delivered from the vendor, and then it's installed in your server so that you can use it for your environment. So really a simple process, and to the end user community, it will look as if every DTM that you need is in your server directly. It'll be a rather transparent process when it goes up to the cloud. If you have networks that support automatic device discovery, the FDT hub automatically handles that, so that as soon as the device is discovered on your network, the hub can be queried for the DTM installed in your server and you're up and running. It's that simple. All of the transfers of DTMs, both from the vendor up to the hub and both to the end user down to the servers, all of that is completely secured in every fashion. So it's encrypted, it's authenticated, and so on, so that we're ensured that what is there is what should be there, and what's delivered to your server is exactly as it came from the vendor. Let's switch gears a little bit and talk about developing for the FDT standard. And for those end users on the webinar here, I think you'll gain some insights in terms of what it takes to be compatible with a standard like the FDT standard. So we do this with tools that we call the FDT common components. These are developer tools, whether you're developing a server, a desktop application, if you're integrating this into a DCS, or if you're supporting your devices, you all would use the FDT common components. So this presents an ecosystem of ready solutions, IIoT ready solutions for the industry. Our complete common component tool set is platform independent. So when you develop using our common components, the resulting code will run on any of the three platforms I mentioned earlier, Apple, Linux, or Microsoft. The common components are out of the box ready, so you can get a common component for the FDT server if you're working on products that would either wrap around an FDT server, or if you just want to offer an FDT server, or if you want to offer an FDT service in the cloud, you could use the FDT server common components. Similarly, if you're more interested in our classic desktop environment, we have the FDT desktop common components available. And then if you're supporting individual devices and you would like to create the driver, the DTM for your device, you would use the FDT DTM common components. The server automatically comes and the DTMs automatically come with OPC UA integration enabled. So the really nice thing from a vendor perspective is if you're creating a DTM, you do not need to do anything special to make it compatible with OPC UA. The standard is written in such a way that your DTM will automatically support OPC UA. Very powerful feature. And all of this is done in a very modern development environment. So all the customization that a vendor might do takes advantage of modern web UI tools, which is HTML5 and JavaScript. This really opens up a much larger developer community to support these type of projects, as there's many more web UI developers out there than other platforms. And as always, the FDT Group realizes that vendors want to be able to distinguish themselves in the marketplace. So while we prescribe a lot of requirements and a lot of features that have to be supported, we leave lots of room so that vendors can show what's unique about their products, enable unique features, add capabilities that maybe we didn't think of from a standard perspective that they think would be beneficial to their marketplace. And then we also made sure that the standard was capable of supporting the development of apps. And we've offered many examples in the industry that you may have seen for that, such as an app that your maintenance people could have on their smartphones. So as they're walking through the factory or the facility, the smartphone geolocates where they are, and if there's any equipment in that area that has raised its hand as in need of attention, the FDT app could automatically alert that maintenance person that, hey, right where they are passing by, there's something that needs their attention, so that they're able to give it a quick look without having to come back to that location. And of course, the sky's the limit when it comes to app development, and we're really looking forward to what the vendor community and the app community do with that capability of the new FDT standard. If you are developing DTMs, the drivers for the devices, there's a number of different kinds of DTMs that you could develop. You could develop them for individual devices. You could develop a DTM that interprets the description language for a particular network. You could also have a universal DTM that works based on some key features of a particular network for all the devices on that network. Or you could also be creating DTMs that support network gateways, protocol converters, and those kinds of things. But in any case, any DTM that you develop ultimately goes through a certification process that the FDT requires to make sure that the device driver is compatible with the standard and as a result compatible with all other DTMs in the marketplace and all the server and desktop applications. And you have an overview here of how that process works. We've developed a tool called the DTM Inspector. It's a software tool that automates most of the checking of the DTM to make sure it's complying with the standard. Those run through the DTM Inspector and then are certified by independent test labs as having passed the necessary requirements of the standard. And once that's accomplished, that DTM then is automatically routed up to the FDT Hub, where it's available then to the entire end user community to be able to automatically download them to their server. From an FDT server perspective, you can take the FDT server common components and you can compile them, and you basically have a fully functional FDT server, including the OPC UA server and the web server are all integrated into our tool set. So there's no need to spend much time on getting those components working because they are immediately available. But most vendors will take that server and wrap other features around it, such as if they're using it as an asset management tool within a DCS environment, for example, they might integrate the project structure that's within the FDT server to the project structure that they would use in their DCS system. And again, here the sky's the limit in terms of what people might do. There certainly is going to be a group of vendors that'll even offer FDT as a service by taking the server, hosting it in a cloud environment, fully configured, ready to go, and you simply subscribe to their services to take advantage of it. So overall, coming back to this overview of the FDT server, you can see the really powerful capabilities of the server, highly extensible, highly scalable. It can run on any operating system that's out there in the industry. So we think it really has changed the game in terms of how people can take advantage of the capabilities that FDT is so well known for. So let's talk a little bit about some of the benefits that comes from this new FDT environment. From an end user perspective, there's a number of things. First, it fully enables secure remote access of all functions. Everything can be done remotely, provided, of course, you have the right security privileges. So you can be sitting in the comfort of your home office, You can be traveling between facilities. You can be in another one of your facilities and still remotely access those functions that you need to be able to keep your facility running, to see the data of your facility, and to make sure that your facility is producing at the level that it should be. You can seamlessly integrate all the industrial networks into one project view. So, we would like to believe that homogeneous network standards are a reality in most cases. Most end users have to deal with multiple networks within their facilities, and the FDT standard seamlessly integrates those into a single view. You get the advantage of the scalability, so you can roll out a small project to start with if you'd like, or maybe you've got a trouble spot where you'd really like to focus some activity around related to the FDT standard. But you can then take all of those lessons learned and easily scale it up to a full enterprise cloud level application. You get secure access to all the devices, and the interesting thing about this is there is no intervention by the PLC or DCS to get that access. So in the past, it was often the case that if you needed some data passed through OPC UA to some higher level business system, you had to make changes in the PLC or DCS to enable that path. Since the FDT standard and the server sits at a peer level to those systems, the FDT server can directly access those devices and present the data that you require. We support all the wireless mobile platforms, so you can access this thing by 4G, 5G, Wi-Fi, whatever the case might be. There's no limitations there from either a security perspective or an architectural perspective. We enable full IT/OT integration, particularly through the OPC UA server that's built in. Your IT organization, if they're authorized, can browse the structure within OPC UA and directly access information that they seek to integrate into dashboards, MES, whatever it might be. And you have the confidence from built-in multi-layer security models that leverage industry standards in our many years of experience with role-based security in the FDT standard. And finally, all certified DTMs are automatically accessible from the hub, no browsing required. They're just simply appear within your server environment so you can immediately get to work with the job at hand. From a device and system supplier perspective, we see that this architecture will empower new business models. So the idea that a bottling line, for example, could come with the asset management features built in that the bottling line manufacturer would support is readily deployable with this standard. State-of-the-art platforms that's completely secure from a skid to cloud environment that's all built into the standard from the get-go. The multi-layer security, of course, helps protect the brand value of the vendors. Every vendor has made a conscious effort to ensure that their deliverables to their customers are secure, and the FDT 3 standard continues to support that security model by layering in additional levels of well-accepted security in their deliverables. We have a fully platform-independent application, including the OPC UA server. So it is pre-wired in the common components. You do not have to be an OPC UA expert to be able to take advantage of it. It's all ready to go right out of the box with the common components. Our environment is designed to be standalone, but it can be readily integrated into larger control or asset management solutions, as the case may be. And we maintain our FDT desktop environment for full backwards compatibility to the installed base. So this is the new standard and some of the benefits we see there. Let me just bring you up to date in terms of where we are today with deliverables from the standard. So the standard itself is now available. We are in the process of scheduling the updates to the standard with IEC, ANSI, and GBT. So we come into our normal maintenance activities with those standards organization, and the new FDT3 standard will be brought into those groups for their approval and finally acceptance into these standards bodies. All of our developer tools are immediately available. So the server, desktop, and DTM common components are available for immediate development of products. We have a new style guide with a responsive design. So with this web browser-based environment, of course, you're presented with many formats of visualization for the end user, many resolutions, aspect ratios, and so on. And our style guide deals with that, as well as virtual keyboards and all the other things that come with it. That's immediately available. And we are in the process of releasing all the communication annexes. And in our terminology, these annexes are what make all the networks work with the FDT standard. So we've released the HART annex and Profibus annex. We're about ready to release the SIP annex, and an IO link annex will be towards the end of this year. We are going to be releasing an IO link interpreter DTM. This is one of the examples where many of the devices on IO link are very simple devices, so we're able to handle it with a one DTM that exposes those features of those devices. And our new public website for the FDT3 standard is launched and available, FDTgroup.org. And of course, there's brochures, white papers, and other things available on that website as well. So that's been a lot of talk about the standard. Let me show you an actual application with the standard. And this is a recorded demonstration of an FDT3 DTM so that you can see what it's capable of, as well as an actual OPC UA demonstration with the FDT server. These were both provided to us from Flowserve, and I wish to thank them for making this available. They're also instrumental in generating the standard. They're one of the sponsoring companies of the FDT organization, and this will give you some insight as to what they see in the new FDT3 standard as well. Well, unfortunately, I hear from our moderator that for some reason the audio is not coming through on that video. So rather than delaying you on the conference here, we are providing this complete presentation to you in your package after the seminar. And I'd encourage you just to click on that video and watch it, because I think it's quite powerful. It shows what a large company like Flowserve sees with this larger architecture and the new things that can be enabled through it. I think it'd be well worth your time to watch it. And I apologize that we weren't able to make it available to you today. So with that, I'd like to turn this back over to Dr. Michael Gunzer at CodeWrights, who will wrap up the presentation, and then we'll open up the session for questions and answers. Michael?
Yes, thank you very much, Glenn, for the very interesting presentation. Yeah, I would like to conclude this and wrap up this with by giving you a short overview related to our service offerings for FDT. Next slide, please. Yeah, of course, CodeWrights offers a full range of services related to FDT technology. So we offer consulting services such as concept development or workshops specifically for migration from FDT, from previous FDT versions 1.2 or 2.0 to FDT 3. We also offer development services, of course, such as DTM development or also mobile app development or OPC UA-based applications. Also test and certification services. So we have an in-house test laboratory. And our claim is to be your easy to do business with partner. So therefore we carefully listen and understand to your demands, then make decisions together with you and implement accordingly. Next slide, please. Yeah, and one example regarding migration to FDT 3 is based on our well-known iDTM. So this is also an interpreter DTM, and we have different variants of this product line available. So there is an iDTM EDD, which is an interpreter DTM that takes EDDs, so electronic device descriptions, as an input and converts them at runtime to a DTM or to a DTM device type. So this means you just need an EDD for your device, and with iDTM you can use it in any FDT frame application today. iDTM EDD supports only FDT 1.2. But then we have iDTM FDI, which is a newer version of this product that supports FDT 1.2 and FDT 2.0 today, and can also take FDI device packages as an input. So this is what Glenn talked about before, so that it is possible to incorporate FDI device packages also in FDT applications. In future, we intend to provide this also for FDT 3. And this means that then that this will be an quite easy migration path if you need to support many field devices at once, also including mobile UIs then. Okay, so we have finished the presentation for today. I would like to thank Glenn again. And now we are ready to answer your questions and listen to your feedback.
Yeah, thank you, Michael. We're both here, and feel free. There's a little red hand on your toolbar there. If you click on that to raise your hand that you have a question, our moderator will acknowledge that and unmute your microphone, and you can ask it. Or if you prefer not to do that and would just like to type in a question, you can do that in the questions section on your toolbar as well. I do want to mention that as part of your deliverables for attending this webinar, you will get this entire slide deck, a link to that video. You'll get the newest FDT 3 brochure that includes a lot of the graphics that you saw here and some more explanation. And you'll also get our latest white paper that was produced through interviews with key industry vendors and what they saw in the new FDT 3 standard and what it enables in their architectures and marketplaces. And that's just released. So take some time to look at that. I think you'll find it to be quite interesting and insightful. And with that, let me pause and check with our moderator if we have questions. We do. So our moderator will acknowledge you and open your mic, and feel free to ask the question. Go ahead if you've got the question. You should be unmuted. Nope. Looks like some people raised their hand, but then got mic shy, I guess. Again, if you have a question, if you do it quickly, we can take it in the written question section. Or I can also offer, if you would like to have a question answered after the fact, that we're happy to do that as well. I do see one question that was typed in here. Is the FDT group participating in the OPAF initiative? And for those who are maybe not familiar with that, this is a group that's working on an open process automation standard, and it's led by some key petrochem companies in the industry, and a lot of the vendor community is participating as well. At current, we're not an active member of it because many of our sponsoring member companies for the FDT group are, and they've been addressing it from that perspective. That may change in the coming year. There's been a few of our members that have asked that we join OPAF actively, and so watch for that to see if that happens here in 2021. We certainly are supportive of their activities, and you may see in some of the writings from that FDT standards get mentioned in terms of integrating with some of the things that are being engineered there. Any other questions? I'm looking at the list here to see if anybody else. Go ahead, Michael.
I said we got a few other questions during the talk that I already tried to answer. Maybe we should repeat this.
Yeah, go ahead, Michael.
Yeah, so one of the questions was how is FDT related to OPC UA? This is so the FDT server, as we have seen then later in the presentation, can provide access to device as well as plant information through an OPC UA interface. And in order to make this possible, we have defined a mapping specification to define the mapping of FDT objects, so for the devices, for example, and data to the OPC UA DI information model, which is for device integration.
Yeah, and I should mention that was done. We actually had the OPC Foundation and the FDT group formed a joint working group to be able to do that, because the OPC organization was very supportive of that activity. And what Michael just described was the result of that has been very well accepted in the industry. So we really appreciate the direct support that the OPC Foundation offered us.
Okay, yeah, then we got another question regarding the installation of FDT3 DTMs. So does FDT3 allow for the addition of required DTMs for a device without having to run an installer or restart your FDT server? And yes, this is indeed possible. FDT3 DTMs are not installed anymore by a kind of Windows installer package. So it is basically done by a kind of copy deployment, and therefore, as Glenn also explained in the presentation, FDT server can access and download required DTM packages from the FDT hub at runtime of the server, and you don't need to restart the server.
Yeah, then the last question there that I see is the interesting one about our DTMs secured or signed in some way. And the answer is yes, they're actually twice signed in that regard. The DTMs are signed by the vendor through digital certificates, so you can directly see that the DTM came from the vendor and has not been altered since the vendor signed the DTM. And then the FDT group also signs a digital certificate to certify that that particular DTM has passed all the certification requirements that the FDT group requires. And so it really is a double signed environment, which should give you good confidence when you go to utilize that DTM from the FDT hub. Then I see one more there, Michael. I don't know. I don't think you answered this one yet. It maybe just came in. Is how do we download the PowerPoint video? You'll directly get a link when we end this session. You'll get all of that in your email that you registered with. So look for that in a few minutes after the end of this session. And I think that concludes the questions, Michael.
Yeah, I think so too. Yeah. Get any more? Oh, yeah. Okay. So then, yeah. Let's thank you all again for your participation, for your interest in FDT and especially FDT3. And as I said in the beginning, we are really excited now to see more and more products coming to the market, and yeah, see what FDT3 can do and how it can really help to progress and accelerate your digital transformation. And we would be very happy to help you with that.
Yeah, that's great. And I want to thank you again, Michael, and your staff for putting this all together and for the leadership that you've shown in the FDT group throughout all the years. I think it has come together very nicely. Thank you.
Thank you.
And with that, I would just say if there's any material that you don't get that you would like from the FDT group, we're happy to support you in any way you can. Feel free just to email us at info@fdtgroup.org, whether it's copies of PowerPoints or brochures or white papers or whatever you need, or if there was a question that we didn't cover, feel free to come back to us with those questions on the side. Thanks again.
Thank you very much and have a great day.